Right, now we have lesson 7.5. It's the last video for Unit 7. We are looking at difference of two squares and how to factor them completely. So the difference of two squares is anytime you have a binomial that looks like this, a squared minus b squared, we can factor it into one binomial, a plus b, times another binomial, a minus b. And this comes from your kind of those special case products from Unit 4. Before, we had a spot where if we did a plus b times a minus b, then it would just become a squared minus b squared. This would be the product of them. Okay, so this is, again, just working backwards from last unit. Now, as before, always, 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 if you can, factor out a greatest common factor first. Every single time when you're factoring, try to take out the greatest common factor first. Now, the biggest part of what we're going to be doing today is, first off, recognizing one monomial as a different monomial squared. So, for example, 9x squared is like saying this monomial, 3x squared. It's like this whole thing is being squared. By that I mean it's like doing 3x times 3x. If we do 3x times 3x, 3 times 3 is 9. That's this piece here. X times x is x squared, this piece here. So we can call this whole monomial, 9x squared, we can call it this piece, 3x, just its own piece, all of that being squared. Same thing, if we have 25y squared, we can call that this piece 5y squared. 5y times another 5y. 5 times 5, 25. Y times y, y squared. So the first thing we need to do in each of these is recognize one monomial, something like this, as being another one squared. So let's look at how these will look in the end. Remember, our the difference of two squares formula looks like this. A squared minus b squared equals one binomial, a plus b, times another binomial, a minus b. So if we've got 16v squared minus 9b squared, again, first we have to recognize each of those as one monomial squared. If we have 16v squared, square root of 16 is 4. 4 times 4 would be 16. Square root of v squared, or what times itself would make v squared, would just be v. So this whole monomial is 4v, and to make it into the 16v squared, we're taking that whole monomial and squaring it. So we recognized that this piece is the same as this piece. Okay, now we're looking at the next piece here, 9b squared. Square root of 9 is 3. Square root of b squared is b. So that whole piece, the 9b squared, is the same as saying 3b, that whole amount, squared. Okay, so we changed each of these into a different monomial being squared. Now, if we look at it, this 4v, that's my a value. That's in the red. This 3b, that's my b value over here. That's in the blue. So over here, everywhere in red, all of the a values become 4v. All of the blues, all of the b values become this 3b. And I literally just plug all of these into this formula, or this form. So this becomes 4v plus 3b and 4v minus 3b. It's those two binomials being multiplied together. Okay, and I won't do this on every one, but on this one I'm going to double check to make sure that this all works out. If we FOIL this, 4v times 4v is 16v squared. 4v times negative 3b is negative 12 VB. 1V and 1B. Starting with 3B. Do that times 4v becomes 3. Oops, not 3. Sorry, this should be a 12. VB. 3b times another 3b, but this one is negative. So negative here and positive here becomes negative. 3 times 3 is 9. B times b is b squared. Okay, so these are all the terms I got from foiling this out. Notice we have a minus 12VB and a plus 12VB. So these cancel out when we combine our like terms. And the only thing that's left is 16V squared minus 9B squared, which was this original piece anyway. So all of this stuff, get rid of what I drew here, these two binomials, this one times this one, these are the two factors of this original polynomial. Okay, it cleans it up a little bit because now we don't have anything squared. These are all just first degree monomials or first degree terms. Let's try it with this one. We have 27h cubed minus 3h. Okay, again, like we said before, always factor out the greatest common factor first, if you can. In both of these, we notice we can take out a 3h. 3 is the biggest number we can take out. Both of them have an h with them, so we can take that out. What's left over? 9h squared minus 1. Because 3h times this one would become this. 3h times negative 1 becomes this negative 3h. So this 3h is going to stay on the outside still. 9h squared and then minus 1. We can recognize that as two different monomials squared. 9h squared is the same as saying 3h, this amount, squared. And 1 is the same as 1 squared. So now we've got it into a spot where we can recognize it like our form from up here. 3h is our a value now. 1 is our b value, so we just plug it into these spots up here. 3h is still a factor on the outside. And then the two binomials that are created, one is 3h plus 1, one is 3h minus 1. So in the end, we've got 3h is being multiplied by 3h plus 1, and that's being multiplied by 3h minus 1. So three different factors. Looking at these two examples, we can notice that in this case, we have 9 minus 4. Now, yes, these have a y cubed and an x with them, but we're just looking at the numbers at first. 9 we recognize as 3 squared, and 4 we recognize as 2 squared. So at first glance, we might be tempted to think, oh, we can definitely break this up into two things squared because we have those correct numbers. When we look more closely, though, y cubed, that is not a square number. This power of y is not an even number, so we can't use it as a square. Same thing with the x. This x power is 1. It is an odd number, so we can't use it as a squared number. It's not x squared or like some number squared to get there. So in this case, we would not be able to factor this one. Same over here. Even though we have this 4 and this 9, so we might think, okay, that's 2 squared and that's 3 squared. Oops, squared. We might think that these would be a difference of 2 squares, but they are not. These two do not work for us. So we'd say with these two cases, even though 9 and 4 are both square numbers, the variables with them are not. So neither of these polynomials are factorable. To help you along, let's write out a couple of what the square numbers are. If we have 1 squared, that becomes 1. If we have 2 squared, that becomes 4. Oops, I'm going to make a nice long list. If we have 3 squared, that makes 9. 4 squared is 16. 5 squared would be 25. 6 squared would be 36. 7 squared would be 49. 8 squared would be 64. 9 squared would be 81. 10 squared would be 100. 11 squared would be 121. 12 squared would be 144. And 13 squared would be 169. And let's cut it off there. That's a nice list. These are a list of all of our square numbers. Make this, whoops, that was too small. That's still a little too small. We'll go right there. Okay, so all of these are our different squared numbers. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. If you recognize any of these as your coefficient, you can change that into some number squared. All right, looking at this example, we've got 121 minus 4b squared. Well, 121 we just said was 11 squared. 4 we remembered as 2 squared, but we also have this b squared part at the end here, so it's going to be 2b. So we have 11 squared minus 2b squared. So 11 is our a, 2b is this b value. We just plug it in exactly like we have it up here. 11 goes into these two spots. 2b goes into these two spots. So we have 11 plus 2b as one binomial. That's being multiplied by another binomial, which is 11 minus 2b. We have a couple more challenging problems here. This is applying a technique more than once. I'll show you what that means in a second here. For this first example, we've got 625 minus x to the 4th power. Now this one wasn't on our list, but 625 is actually 25 squared. 25 times 25 is 625. If you ever need some help figuring out if your number is a square number, type it into your calculator. So 625. And depending on your scientific calculator or graphing calculator, however you have it, you'd either put the square root after it or type in the square root part first. So you're looking for the square root of that number on your calculator. Hit enter, and it should tell you that, oh, that one is exactly 25. Same thing with this x to the 4th. Because of our monomial powers, we know that power to a power means multiply. So if we want something to be squared or something to the 2nd power out here, we would take this number divided by 2, and whatever's left gives us this piece here. Okay? So with that in mind, these are our two new values. We'll plug 25 in as the a value, so all of the red pieces here. We'll plug in x squared as our b value, so all of these blue values, and we'll make it look just like this form. When we do that, we have the binomials 25 plus x squared and 25 minus x squared. When we look at this though, this binomial, 25 minus x squared, is still a difference of two squares. 25 is 5 squared. X squared is the value x to the power of 2. So we can break those up into 5 to the power of 2 and x to the power of 2. Now because these two is just this factor, just this binomial, the other binomial, the other factor has to stay. So it didn't go anywhere. It's still there. It's still part of our solution. It's just kind of separate because that one we're finished with. We're already done with that one. Now, plugging these values, 5 and x, in for our a and b, or our red and blue values, this piece, this factor, would be broken down into 5 plus x and 5 minus x. Don't forget, we still have this factor on the outside, so it would become 25 plus x squared. So in the end, we have 3 different factors for this one, 25 plus x squared times the binomial 5 plus x, and times the binomial 5 minus x. So 3 different factors being multiplied here. That would give us this piece. And last but not least, this example says we have 4a to the fourth minus b to the fourth. We can recognize that as 2a squared, that amount, to the second power. Subtract b squared, that amount, to the second power. Now that we've set it up to look like this, a difference of 2 squares, we just plug everything in like we did before. This 2a squared was our red value, all of our a's here. So 2a squared at the beginning and 2a squared at the beginning. B squared was our blue value, is this one. So it gets plugged in here and here. Positive b squared and negative b squared. Or should I say plus and minus. So our two factors, our two binomials, are 2a squared plus b squared and 2a squared minus b squared. So we have two different pieces. Now, if we look at this piece, we might be tempted to say, all right, we have an a squared and a b squared, so this must be a difference of squares because we have a minus here. We might be tempted to go on like we did with this piece. However, 2, this piece here, is not a square number. That is not any certain number squared. So we would say at this point we would actually be done. So even though the variables are both squares, a squared and b squared, since 2 is not a square number, we would stop at this point. We'd be all done factoring this. So this would be the most factored form for our original polynomial here. And that'll be it for 7.5.